Alright, today we're working with linear functions, so basically linear equations. So let's just review a couple ideas. Different ways we can represent these. One way is standard form, and in that case both the x and y are on the same side of the equation, especially when we deal with systems of equations in the future. This is a common way we'll write equations of lines. So something like 3x plus 5y equals 30. Now, to me, a more useful way, most of the time the way we're going to see them, is in slope-intercept form. Now, this should look really familiar, I hope. Y equals mx plus b. If that doesn't look familiar, please write it down. Make note of what these parts represent, okay? So m is the slope, and b is the y-intercept. So something like this. This is actually the same equation as above. I just rearranged it. So y equals negative 3/5 x plus 6. Now the value of that, it's got the slope right there for you, and it's got the y-intercept. So this is a really nice form to go graph, to analyze lines in. Now a quick recap, review from our past. X-intercept, y-intercept. Well, x-intercept, where the graph crosses the x-axis, right? And that happens where y equals 0. And y-intercept is where you cross or intercept the y-axis, and that happens at x equals 0. So a little example, find the x and y intercepts for this equation. Well, to get the x-intercept, you just plug in 0 for your y value. Okay, and you're going to see where it crosses. So plug in 0 for y, and we get 3x equals 30. Divide your 3 over, and notice you get x equals 10. Or in other words, 10... well, that's not a 10. 10, 0 is where that graph crosses the x-axis. Okay? How about your y-intercept? Very similar, except you're going to plug a 0 in for x. So now we get 5y equals 30. Divide that 5 over. Y equals 6. So the point 0, 6 on the y-axis, right, is where that graph crosses the y-intercept. Now, moving forward, slope, steepness of a line, right? You picture a line, how steep it is the slope. We could have positive slope, negative slope, horizontal line is going to be 0 slope, vertical line is going to be undefined. Okay, you think about that. And we often describe this as rise over the run, or more technically, a change in the y. That's what's happening in the vertical direction, rise, over the change in the x, in the horizontal. And then we have this little formula. So y2 minus y1 over x2 minus x1. All that is a y value minus a y value, change in y, our rise, over x2 minus x1, x minus x, our run, our change in our x values. Okay, and again, you've done this before. Let's just do a quick example. Find the slope of the line that goes through these 2 points. Now it doesn't matter which one you start with, okay? I'm going to do this one. So let's do 13. So my slope is 13 minus 8, y value minus y value, over 5 minus 2. Notice what we get, 5/3. What if I had started the other way? Okay, what if I did this way? 8 minus 13 over 2 minus 5. Well, I'd get negative 5 over negative 3, which is still 5/3. That's what I mean, it doesn't matter, okay? I chose this way just because I knew it was going to give me positive values at the start. But it really doesn't matter which way you go. How about a little problem like this? They ask us to rewrite this equation in slope-intercept form. Again, slope-intercept, y equals mx plus b. What if we wanted to rearrange? Well, you just rearrange it, right? So let's see. We'd have 2y equals negative 4x. We subtract it over, we'd have to add that 6. Plus 16, then divide our 2 over, so y would equal negative 2x plus 8. So same equation, same line, just written a little different way. Just rearrange it basically, okay? Here's a couple typical problems you'll run into. Write an equation for a line with a slope of 2 that goes through this point, and put it in standard form, okay, whatever they want. Well, they show different ways to do it. Here's how I like to do it. Y equals mx plus b. Let's plug in what we know. Well, m is 2. This is an x and a y. So let's plug those into the equation. So negative 2 equals 2 times 4 plus b. Notice b is the only thing I don't know. I'm going to figure it out. So negative 2 equals 8 plus b. Let's subtract that 8 over. Hey, b equals negative 10. Now I know my equation. So it's y equals 2x minus 10. That would be usually just fine with me. They say standard form, so let's just subtract that over. So negative 2x plus y equals negative 10, or we could take a negative through there. 2x minus y equals 10, whatever they want. Okay, there's a bunch of different ways we could write that. What if they give us just a couple of points? Okay, 2 points. Well, it's very similar to what we just did, except first we want to find the slope. So let's get that slope first, and then it's an identical problem. So let's do 4 minus negative 1. So I'm doing y minus y, and then my x, 4 minus negative 4 there. So that's going to be 5 over 8. So my slope is 5/8. And now it's an identical problem. You can use either one of these points. Let's just use this one. So 4 equals 5/8 times 4 plus b. And so 4 equals 20/8, which is 10/4, 5/2, right? Yeah, 5/2. So 5/2 plus b. Then we subtract that. So 4 minus 5/2 equals b. And 4 would be 8/2 if I just rewrite that. So that would give us what? 3/2. So b is 3/2. So now we can write the equation. So y equals 5/8 x plus 3/2. Hopefully I did that right. I know I'm trying to go quick to keep these videos a reasonable length, kind of introduce things to you. Alright, couple quick things. Let's just summarize here. Horizontal lines, right, nice and flat, have a slope of 0. Excuse me, your y would be constant. So if you plugged it into our slope intercept, it would look like this: y equals 0x plus 3. Well, you don't need to write that 0x, you just write y equals 3. Y equals 5, y equals 7, whatever the y value is, crosses through there. Okay, vertical lines, on the other hand, have an undefined slope. Because if you think about rise over run, if your run was 0, then you're dividing by 0. Excuse me. And so you can't do that. So equation for these is just going to be an x equals something. So like x equals 5, x equals 10, whatever. That's going to be a nice vertical line right through the x-axis. Now, parallel lines, you know they never cross. Well, they have the same slope, okay? That's how they're not going to cross. They have the same slope, different y-intercept, of course, but same slope. Perpendicular, on the other hand, crosses at 90 degrees, right? Very specific angle. So these are negative reciprocals of each other. So for example, if one slope was, let's say 2, a line perpendicular to that would be negative 1/2. So reciprocal, just flip it and then change its sign. See how that works? So perpendicular lines have slopes that are negative reciprocals of each other. All right, hopefully this is feeling kind of familiar, and I'll help get you through this lesson today in good shape, I hope.